We now begin mechanics. Mechanics is the science of motion. Motion is perhaps the simplest of all physical phenomena. It was the first physical phenomenon to be completely understood. Okay, let's begin by first of all going all the way back to the ancient Greeks, specifically the ancient Greek civilization that started to flourish several centuries BC. This particular culture is given a lot of credit when it comes to the beginnings of science. And the reason for that is because this was the first culture to view the universe as a mechanism, that is, something that could be understood. All cultures prior, and certainly a lot of cultures since, have thought of the universe as simply being divine, something that is beyond the realm of human understanding. The ancient Greeks, however, thought otherwise. When it comes to motion, everything that the ancient Greeks thought about motion could be summarized into three statements. The first of those statements is what is called the geocentric universe. The Earth is the center of the universe. It is stationary at the center of the universe, and all celestial motion that we see in the sky is perfectly circular and centered upon the Earth. All celestial motion is perfectly circular and centered on the Earth. Now, for those of you that are enrolled in Conceptual Physics AB, Physics AB, and Honors Physics AB, you have already seen in the opening unit of this course that this statement is incorrect, culminating with the discovery of Kepler's laws of planetary motion. For those of you that are enrolled in AP Physics C, you will see that material at a later date. However, it is the other two statements with regards to motion near the surface of the Earth that are important for our purposes here. Once again, this is according to the ancient Greeks. According to the ancient Greeks, heavier objects fall faster than lighter objects. Now, if you just observe the behavior of falling objects around you, it is very easy to reach this conclusion. At this point, however, I want you to pause this lecture, and I want you to access the video called "Do Heavier Objects Fall Faster Than Lighter Objects?" that demonstration that I've posted for you. Make sure that you watch that demonstration now. Okay, now that you've seen that demonstration, I describe in that demonstration the mistake that the ancient Greeks made. The ancient Greeks are given a lot of credit, deservedly so, for the beginnings of science, but they never did any experiments. They missed that a crucial step of the scientific method. The ancient Greeks thought that it was good enough to just observe the world around you and then base your conclusions upon your observations. As we've already seen in that demonstration, that particular viewpoint is only going to get you so far, and it's going to lead you to some mistakes. Okay, and then third, once again, this is according to the ancient Greeks. According to the ancient Greeks, all moving objects eventually come to rest. It was thought by the ancient Greeks that there was something special about an object being at rest. They referred to it as an object's natural state. An object's natural state is that of rest. Once again, if you just observe moving objects around you in the everyday world, it is very easy to reach this conclusion. So for example, take an object and drop it vertically, and it eventually comes to rest. Take an object, say this eraser, and slide it horizontally across the surface. It eventually comes to rest. Now, in addition to the first statement being incorrect, numbers 2 and 3 are also incorrect. They were experimentally shown to be incorrect by the Italian astronomer and physicist Galileo Galilei in the early 17th century. In order for us to understand, however, exactly what it was that Galileo did experimentally to overturn these notions regarding motion, according to the ancient Greeks, we first of all have to go through a little bit of mathematical background. We have to describe what are called vectors. I will do that in part 2 of this lecture.